friends, my name is Evangeline Wartde. I'm from Physics Department, Assam Don Bosco University, and in this video, I will discuss about Pn Junction Diode. So first of all, what is a Pn Junction Diode? A Pn Junction Diode is an interface or boundary between two semiconductor material type, namely the P-type and the N-type inside a semiconductor. So how a Pn Junction Diode is formed? When half part of a silicon crystal is doped with trivalent impurities and half part with pentavalent impurities, we get a Pn Junction Diode. Here it means that when half part of a silicon crystal, basically we know that silicon is a semiconductor, is doped or mixed with trivalent impurities like boron, and half part with pentavalent impurities like phosphorus, we get a Pn Junction Diode. So in this diagram, we see that it is the unbiased diode because no external source is connected to the diode. So in this diagram, we see that the holes from the P side move towards the N side and the electron from the N side move towards the P side. So it created a positive ion and also it created a negative ion. So it is from a potential or a wall. So this potential, it prevent or block the movement of charge carriers, that is electrons and holes across the junction. This potential is known as a barrier potential. And this region, it is a depletion region. This depletion region is a region where no charge carriers are present. This is the symbol of a Pn Junction Diode. This is the P-type and this is the N-type. Now, I will discuss about the biased diode. And first of all, what is a biased diode? When external source is connected to a diode is called biased diode. Now, let us see what is a biasing condition for the Pn Junction Diode. There are three biasing conditions for Pn Junction Diode, and this is based on the voltage applied. Zero bias, forward bias, and reverse bias. What is a zero bias? When there is no external voltage applied to the Pn junction, means here that the voltage applied is zero and the current I also is zero. Now, forward bias. This is the diagram for the forward bias. When the P-type is connected to the positive terminal of a battery and the N-type is connected to the negative terminal of battery, then the Pn junction is said to be forward bias. So as we see from the diagrams, the holes from P side are repelled from the positive terminal and the electron from the N side are repelled by the negative terminal, and they are trying to move the junction. Due to this, we see that the depletion width will become smaller and that will reduce also the barrier potential. Now if potential difference become lesser and lesser, the depletion region will disappear, so the electron and holes will combine together, so there will be a flow of current from anode to cathode. Now this is the diagram for the reverse bias. When the P-type is connected to the negative terminal of the battery and the N-type is connected to the positive terminal of the battery, the Pn junction is said to be reverse bias. The holes from the P sides are attracted to the negative terminals and the electron from the N side are attracted by the positive terminal of the battery. So the free electrons now, they move away from the junction. So due to this, it increases. As we see the width here, it's become larger. And as due to this, the width of depletion region and barrier potential increases. So there is no flow of current through reverse bias. But under normal reverse voltage, a very little reverse current flow through a Pn junction. So if the reverse voltage is increased continuously at high value, the junction may break down with sudden rise in reverse current. This is called breakdown of diode, and the corresponding voltage is called breakdown voltage. So in my previous lecture, I was explaining about the biasing condition of a Pn junction diode. So now I will explain to you about the VI characteristic of a Pn junction diode. The graph between the voltage applied across the diode and the current that flows through it is called the VI characteristic of a diode. So as we know from the previous lecture, in forward bias we know that the P-type is connected to the positive terminal and then N-type is connected to the negative terminal. So this is the graph. I have plotted forward bias up and reverse bias down. So let us talk about first about forward bias. So as we see that as we increase the forward voltage, the current also increases but very low. But as soon as it reaches certain point, that is in the case of silicon 0.7 volt, the current started rising exponentially. The voltage at which the diode start conducting is known as a knee voltage, and this is known as the knee voltage. And before this knee voltage, the current through the circuit is very low. But as in the case of reverse bias, the p-type is connected to the negative terminal and the n-type is connected to the positive terminal. So as the reverse voltage is increased, we see that there is a very small current here flow through the circuit, and it is due to the minority charge carriers, and this small current is known as the reverse saturation current. If increase the reverse voltage, if we start increasing the reverse voltage, the current remain constant till it reaches a breakdown voltage. This is known as the breakdown voltage. So if we increase for the reverse voltage, the reverse current increases very sharply. We see that as we increase for the voltage, the reverse current increases very sharply. Thank you.